This presentation will be on the mean value theorem and Rolle's theorem. So the mean value theorem is one of the most important theorems you would have to know for the AP. It's one of the three existence theorems that we learned about this year. So it basically states and tells us that if the function we have is continuous on the closed interval and differentiable on the open interval, there has to be some value where the average rate of change equals the instantaneous rate of change. So visually here, we have the point A and the y value is f of A, and then point B and the y value is f of B. So if we take the average rate of change over that interval, which would be this secant line here, there has to be some point over this interval that this average rate of change would be the instantaneous rate of change. So the instantaneous rate of change would most likely be here and here. Drawing is not very good, but just the instantaneous rate of change would be the slope of these two tangent lines. So the point C would be right here, and then another point C would be right here. So we know that this is continuous because there's no discontinuities here, and differentiable because there's no horizontal or vertical tangent lines that would make it undifferentiable. So it could be written in simple terms like this. So let f be continuous on the closed interval of a to b, and I think I said differentiable. I meant continuous on the closed interval of a to b, and differentiable on the open interval of a to b. Then there must exist some point C, so we said here C and another point C here, where from a to b such that the f prime of C, or the instantaneous rate of change, equals f of b minus f of a over b minus a, or the average rate of change. So here's a review of continuity and differentiability, because we really need to know this for these two theorems. So a function is continuous at a point x equals c if the function at that point c exists, if the limit of x approaching that value c of f of x exists, and these two values equal each other. And a function is differentiable if f prime of x, or the derivative of the function f, is continuous at that point x equals c. Also, if f of x is differentiable, so if the function is differentiable, it implies the function is continuous. So if the question says f is differentiable on the interval, it also implies that f is continuous. So here's an example problem for the mean value theorem. So let f be a twice differentiable function such that f of 2 equals 5 and f of 5 equals 2. Explain why there must be a value c for 2 from 2 to 5 such that f prime of c, or the instantaneous rate of change, equals -1. So since it's stated it's a twice differentiable function, we know that it's differentiable, and also it's continuous because differentiability implies continuity. So we can use this equation from the mean value theorem that states the instantaneous rate of change equals the average rate of change, and plug in the values that was given in the problem. So the a value would be 2, and then the b value would be 5. So the ends of the interval are the a to b. And if you plug that in, you get -1, which is exactly what we needed to find in the problem. So you can't just leave it like this. You have to state the mean value theorem. So you'd write out, since f is continuous on the closed interval of 2 to 5 and differentiable on the open interval of 2 to 5, according to the mean value theorem, there must exist some point c on that interval such that f prime of c equals f of 5 minus f of 2 over 2 minus 5 equals -1. And that's all you'd have to write. Make sure you state the mean value theorem because that would give you a point. And differentiability and continuity, you have to make sure you state that. And state this part too. Okay, so this is Rolle's theorem. And is basically just a subset of the mean value theorem. So if you know the mean value theorem, it basically implies this. So basically what Rolle's theorem tells us is if there's 2 points on an interval, so these are the two ends of the interval a and b, and these points, the y values are equal to each other. So in this case, it would be 0. So f of a would be 0 and f of b would be 0. Since they equal each other, there must be some point on the interval, which we would call c, where there's a horizontal tangent line, which basically means the slope of the tangent line equals 0. So if we look back to the mean value theorem right here, so we said before f of b was 0 and f of a was 0 of that function that I gave. So that would be 0 over any number. So we didn't give any arbitrary numbers for b or a, but it doesn't matter because anything, 0 over anything equals 0. Except for 0 over 0, which is undefined, but that's not what the function gave. They're two different numbers. So in words, you would write, let f be continuous on the closed interval of a to b, which this function is, and differentiable on the open interval of a to b, and let f of a equal f of b. Then there must exist some point c, so c is right here, where between a to b such that f prime of c equals 0. So the instantaneous rate of change equals 0, which basically states there's a horizontal tangent line. So here's an example problem of Rolle's theorem. So this is from the textbook. Determine if Rolle's theorem can be applied to f on the closed interval of a to b. If it can be applied, find all values of c in the open interval from a to b such that f prime of c equals 0. So I gave a couple hints here. So first we have to determine if it can be applied on the closed interval. So we have to determine if the function is continuous and also if the function is differentiable. So since this is a polynomial, we know that all polynomials are continuous. And also if you take the derivative of this function, we know it's continuous too because there's no points that it would be discontinuous. So if you, the regular function and the original function and the derivative of this function, they're both continuous. So it's this function is continuous and differentiable. So since we know the Rolle's theorem can be applied, we have to determine if f of -1 equals f of 3. So if you can plug it into your calculator, but simply if you do plug in this a value, so -1, -1 minus 3 is -4, and -1 plus 1 is 0. So f of -1 is 0. And then if you plug in 3 minus 3 is 0, so 0 times anything is 0, so f of 3 is also 0, so both of these f of -1 equals f of 3 because they're both 0. So we can write, since f is continuous on the closed interval of -1 to 3 and differentiable on -1 to 3 on the open interval, and f of -1 equals f of 3, then according to Rolle's theorem, there must exist some point c where on that interval such that f prime of c equals 0. And remember, you have to make sure with Rolle's theorem that each of these 3 points are given. So if the function isn't differentiable, you can't use Rolle's theorem. If f of -1 doesn't, if f of a doesn't equal f of b, you can't use Rolle's theorem. You have to make sure all 3 of these hints are used. Okay, so this is the homework problem I gave, which was from old practice exam. So given the table above, explain why there must be at least one time t between 2 to 10 such that h of prime of t equals 2. So to determine, first you have to determine if it's continuous and differentiable. Never mind. Well, in the problem they stated that it was differentiable. So, but just given the table, just determine if there's a time of h prime of t that equals 2. So you have to determine which theorem to use and state everything like we did in the other problem. Okay, and the second problem is very similar to the other textbook question that I gave. So determine if Rolle's theorem can be applied to f on the closed interval of a to b. And if it can be applied, find all values of c in the open interval of a to b such that f prime of c equals 0. So the function I gave was sine x, and this is the interval. So just use the hints that I gave before, and that's it. Bye.